Hello everyone, it is December 5th, 2023, and we're here for another live stream where we're going to be talking about coding and data science and machine learning and all that fun stuff. I'm so glad that you're here. If you are here, if you're not here and you're watching this later, I'm glad that you're watching it at least later. Hydrin in the chat, already typing sexy beast, which is like right on top of my face right now. And it did text to speech, at least did text to speech for me. Could you guys hear it? Could you hear it? I hope so. Okay, so had a very fun result to a Kaggle competition that just ended. And it's very much in line with the, it's very much in line with what we've hosted here earlier on PogChamps. So if you guys aren't familiar, by the way, I'm pouring myself a beer here to celebrate. So if you're new here, I've hosted some competitions on my Twitch stream supported by the viewers here. And those competitions have been hosted on Kaggle. One of the recent ones that I held, I actually uploaded over 7 years of my own personal health data. Everything from my old Fitbit, my Apple Watches, and I asked you guys if you could predict my sleep patterns given the data. Hey, we got some more people on Twitch. So this goes way back. And you guys did a great job. We had a lot of people participate on that competition. Oh, hey, Try Vanilla JS, welcome. Good to see you. So that goes way back, and let's get this set up. Yeah, anyways, super fun competition that we had. And then recently, Kaggle actually started a competition hosted by the Child Mind Institute to do something very similar. I think it just happened to be, cheers by the way, cheers. Gotta look each other in the eye. I learned that from some of my Austrian and German friends. Oh, that's good. So let's show this. Let's see if this is PogChamps Season 3. That was the corn one. But this is the one that I held, and it was to predict my sleep patterns with my data. And we had a lot of people join. Lots of fun. How many people were in it total? 129 more? Whoa. We had 178 teams on this competition not too long ago. But the recent competition, this one was held by the Child Mind Institute. I accidentally wanted to do that for myself. 8 years of wearing Garmin watch. Ooh, try vanilla. Yeah, upload it. So all my data here, I was kind of nervous about uploading it, but it basically was just like a big data dump from my Apple health data, and all of it's here, like this big XML file. I think some of the winning people actually parsed that XML file to find more information. But the recent competition that just ended 2 hours ago or 3 hours ago, I teamed with the very, very strong Kaggler, Ahmet. And honestly, he carried our team. He completely carried our team. But early on in this competition, I was coming out strong. I was in first or second place for almost the first 2 months. And then everyone started coming back. I teamed with Ahmet. His model was much better than mine. We worked on some post-processing and stuff. And we actually jumped on the private leaderboard from 16th place. This is a very noisy data set. To a private place of 7th. Now, my own single model would have been 20, something, 24th maybe. So this is how much better Amit's model made ours. But I can talk a little bit about my model and how I created it and some of the behind the scenes stuff. So if you're interested in Kaggle competitions, this is the place to be. We're going to just talk about that stuff. Okay, so this is from Advent of Code, which I'm not doing anymore. I decided, I did the 2 days of Advent in Code, and then I was like, I just need a break. Like, I don't want to do more puzzles right now. So I'm going to open up detect sleep. Where is it? Detect sleep states. And you can see some of my code here. By the way, if you're watching on YouTube or something, jump on over to my Twitch channel. I have it linked in the description, and that's where I'll be reading all the chat. So, hey Rob, that comp was really fun. Cheers. Hey, thanks, Futrio. I think that's your English name, but thanks for saying that. I spend like 8 to 10 hours a day writing Python. The last thing I want to do is more Python. Yeah, it is. I read the day 3. Honestly, I read the day 3 of Advent Code, and I was like, I know how to do this. It's just going to take a while. And then what do I get from the end of it? I don't know. If I do it on, I feel like if I did it on stream, it would make more sense. And now that I missed a few days, I don't want to go back. Okay, so let's talk about this competition. First thing you need to understand with this competition is the data. And the way you can understand the data is by doing some data exploration. So these are all my notebooks I worked on throughout the course of this competition. Actually, probably more important than that was understanding the valuation metric. So this I worked on early on in the competition because the way the data was set up is you basically had a bunch of accelerometer data that someone was wearing on their wrist for up to 30 days, I think, about a month of wearing these things on their wrist. Although sometimes they would take them off, so they would ignore those days. But if they were wearing it, then you were trying to predict when their sleep started. So the onset of their sleep up to the minute. You actually were predicting in 5-second data points. But what we found out was that the labels were all rounded to the minute. So it really didn't, even though you had 5 seconds of data to work with, you did better just predicting a slight offset from every minute. And then you were graded using this average precision metric, but it was kind of like a tricky version of average precision where they would do average precision over different thresholds. So they basically would say, okay, you predicted that the person started sleeping at 8 p.m., but they actually started sleeping at 8:20. So you meet the 20-minute window. That would be correct. But in the 5-minute window or the 3-minute window, you missed it if you didn't predict anything in there. And you could actually make multiple predictions throughout the data set. So what I started working on when this first came out was trying to understand this metric. So I wrote a bunch of code to try to understand it as they described it and actually write out what I thought the scoring metric should be. Now, a few weeks later, I realized I might have been late to the party, but I realized that they had released their official evaluation metric code. So that was this. I still don't understand why I got wildly different scores than what their average precision gave, and I'm a little suspect about how their average precision treated false positives. All that's to say, once I knew I had their metric code, then I kind of dropped trying to write this code myself. Is anyone out there done harder than it looks? Yeah. Let's go straight to the hyperparameters of the deep learning model. That's the boring part though, Dark Tobias. Once you're tuning, so I could show you my weights and biases trial runs for this one. Like, I have this filtered. But I had hundreds and hundreds of trial runs of different folds and different data to try to see how well my models were doing. And every time I would tune a parameter, I would sort of see how well it scored using this evaluation metric, the one we were just talking about. And then you can kind of go in here and compare the different runs and see what things I changed. But that was kind of like incremental changes. To me, the most fun part of the competitions are the very beginning, when you just dive into the data and you really don't know what you're doing and you have to kind of figure it out. And then you can be imaginative about how you're going to solve it. You can like be creative in it. Be curious about the data. So all these charts actually showed in those different windows I was talking about before. I was tracking how well I did in average precision for each of those windows. So you could see like my average precision for this 12 steps, which is actually 1 minute window. I was at like a 0.4, but then at the 120 window, which is much wider, I was at 0.85. So the way this metric worked is it took all these different windows and then averaged across them. Now, the interesting thing the thing that ended up really helping me a lot with this metric was that I went through it and I really dissected each of the functions to try to make them faster. Because otherwise, scoring this sometimes took like 30 seconds to score each time. And the way you train these deep learning models is as you're training each epoch, you're watching your training loss, your validation loss, and then you also score your metric. I mean, you could choose to do it less often, but I wanted to score how my model was doing so I could track it as it was training. And each of these runs took like about 2 to 4 hours. So by speeding up this code, this metric code, I sped up the training time by a lot. Now my model still trained pretty slow, but how did I do that? I wrote a time decorator that I used to see which parts of the function were slower. So the left side is the original code and the right side is my code. I removed some of these global variables they had. Yeah, so they were doing iter tuples here. This ended up being slower than just iterating over each one. I honestly forget some of the stuff what I did. I actually used ChatGPT to help a lot with speeding this stuff up. Have any of you guys out there done David J. Jackson? Have any of you guys out there sped up code, just like had as your job to try to make some code that already exists faster? It can be fun sometimes, but then it can also like get boring. Oh yeah, so I also did multiprocessing. That's the big thing with Python is when you're writing code that only uses a single thread, if you can somehow multi-thread that, you can really leverage all of your CPU compute power and make it faster. I forget where I did multi-threading. Here, I guess. Wait, this is metric speed version 2. I think that one, the multi-threading version, I did not get working. So this is the actual version that I use to speed things up. Anyways, so let's actually look at the data. I do that a lot for my job. The easier optimization is to upgrade Python to version greater than 3.11. Oh yeah, changing. Do you guys remember when Python 2 was deprecated and everyone had to upgrade their stuff? That was like, that was painful for a lot of people. So it's little stuff like this that you invest in early in a competition that ends up paying dividends. I did see that someone else posted their faster version of this metric, and I'm guessing it's potentially faster than what I did, or it's probably similar actually, because I'm pretty sure I squeezed out as much as I could out of that metric speed. But let's go here. Yeah, I'm in the right spot. I'm going to open up just like a Jupyter Lab session. And we're going to take a look at the data. The data. So this is going to be our like post competition EDA, so I can show you guys what's going on. So what was the objective? We were given sensor data, and whenever you have data that's like sensor, or whenever you have time series measurement data like that, the main thing that you're interested in is how often are the samples taken. So this was at 5 seconds per sample. And they actually gave it with the timestamp. And so you had like steps and clock timestamp. Now the timestamp stuff did some funky things during daylight savings, as you might imagine. So you would like lose an hour, but your time step would stay the same. So you couldn't just use a clock like a normal wall clock and expect it to work fine during those times. We were given 2 data values. We were given the ENMO. I don't even know what this stands for. This is like the activity. And we were given the Z-axis angle. I think it was the Z-axis angle. So let's show this data. And I have some visualization tools that I made, but let's read this Parquet data. And they actually gave this in a huge Parquet file, which I wasn't that big of a fan of because the Parquet file itself was a few gigs. So let me go actually into here and we could see the size. Yeah, so the size of this was almost a gigabyte, which when you read into memory, because a Parquet is a very efficient format of saving it, ended up being quite large. So, and it took a while to read. Like you could see this is running for a while just to read this data. Especially on the Kaggle notebooks, this was a problem because you would run out of memory. And once your kernel runs out of memory, the Kaggle kernel just dies and you don't, it won't continue. Need more RAM and more GPU. I have plenty of RAM and GPU to handle this, at least locally. That's where I'm running it now. But like, so if I look at, that's my GPU. If we look at my system processes right now, it's like 15 gigs of my memory is being used right now for this one file. So it says it's 3.3 gigabytes. And then like if you start adding features to this, like this is just that angle Z and this ENMO, which is the activity. If you started adding features like a rolling feature about with angles or something more than that, then it starts getting really big real fast. The thing is, this data is split by series IDs. So these series ID, not like that. Series ID is basically when one person wore the sensor device for whatever period. It could be weeks. It could be a few days. It was given a unique series ID. So really, I thought they could have saved these files as unique series IDs. It just would have made things easier. I ended up using polars in some of my code because then it could read in just a subset of this Parquet file into memory and I wouldn't have to worry about it. But I also ended up, in my solution before I merged with Amit, writing multiple files to disk and then deleting it out of memory so that I could read them in individually. Because when you're running inference, you only really need one at a time, one series at a time, right? So you could see the series range from being kind of long to short. Let's see how many unique there were. $277 unique ones in the training data set. Now the test data set, the leaderboard data set, I forget they said in the data section. I think it was about 250 also. Full test set contains 200 and the public leaderboard consisted of 25% of that. So 50 series were in the public leaderboard and 150 were in the private. Now we ended up trusting our cross-validation score more than this public leaderboard because we knew how inconsistent it was with our cross-validation score. I could probably show you some submissions where a cross-validation score went up, but this public leaderboard went down. Since it was smaller data than the private, we kind of expected it to go higher. Also, our cross-validation score was about at 0.837 for this metric. And the public leaderboard was much less than that. So I guess some of the noisier samples happen to be in the public and not the private data set. Questions. What command is used to change Jupyter to dark mode? So I think it has a built-in dark mode, but under this theme, I installed something called Solarize Dark. This one. Put that in the chat for you. It makes it look like this. I like this theme. All right, so let's just slice. I actually think this first one was a bad one. So let's do this last one. Let's get just where this last series exists. Reset the index. Copy this into an example. I did mean double equal signs. Thank you, Python. Let's also import some other stuff I know I'm going to use. And load Jupyter Black so it'll make stuff. Oh, is it Lab Black? Needs a T. There we go. All right, so this example is just going to be one of those series. Spelled Jupyter wrong. Ugh, I always check the chat too late to be helpful. Okay, so we can see that this has this timestamps. These timestamps you can see are rounded, but jump every 5 seconds, and that's at the same frequency of the steps increasing. So every data point, every series started at step 0 up until the end, however many 5-second increments that took. And then you can also see this negative 400 means that that was the time zone with this timestamp. So in some of these, it goes from negative 400 to negative 500 because the time zone changed, but the step would still jump one at a time. So if I set the index just to be the step, and we look at this angle Z feature, you can see it's like a lot of noisy stuff. So let's actually take df example timestamp and do to date time, because this is not a date time. UTC equals true. Make this example column as a date time. And then we could do something like day, but that would be day of. Just get the date of the timestamp. Right? And then for date, data in this group by date. And then we can plot this, break out of that. So you can kind of see the data a little bit cleaner here. Title equals date of our date. Realizing you guys can't see that. Let's make this a little smaller, this chat a little smaller. You guys see that okay? Is that okay? All right, so now we're just going to look at one date. This is the one date, and oh, maybe I can do a plot show each time. All right, so the angle Z is the Z axis. So this is like when your arm is horizontal and just still horizontal. That's probably when the person's sleeping. And like there's a bunch of papers out there that talk about this being a really strong feature. Now, I still wish they would have just given us the raw accelerometer data, because the raw accelerometer data has X, Y, and Z axis, and it has it at every 5, I think it has it more than every 5 seconds. And then we could have created our own features ourselves. But they decided instead to give us just the Z-axis feature and this ENMO, which is like the summation of all the energy across all axes or something like that. But you could kind of visually see when the person was sleeping, because they had these long lines. I don't know if these jumps are like when you roll over in bed or something. But yeah, so you could see here that there's some drift in these, but it makes sense visually where you might guess the sleep is. Now, let's also show that second feature, but let's make that on a different figure axis. Because if we put it at the same scale, this angle goes like all the way from -90, I think, to +90. But the other feature is at a very different scale, so we kind of have to rescale it. Or put it on a different axis on the same plot. You'll see. So that's the first one. So we're going to make a second axis using this twin X, which basically make an axis on the right side of our plot. Let's try to do this. Remind me what the columns are. It's E N M O. That's the feature that I'm looking for. We'll put this on axis 2. None of data.columns. Oh, I did not. ENMO is what I wanted to show. Where is it? Oh, wait, it's the same color blue. So let's do color equals orange or something to make it stand out. Okay, so you can see like this is really active periods is when this spikes. And as you might imagine, people aren't very active when they're sleeping. So you can kind of visually see where the sleeping is. But the hard part about this is actually getting the prediction of when the sleep starts and ends at the exact right time. Because you have to be good enough that you can get it within 1 minute of when the actual sleep occurred, or actually when the labelers said that the sleep occurred. So we haven't even looked at that. So let's read in the events. So these are like our labels. So the labels are either onset, that's when the person went to sleep, or wake up. So the way I can plot these, kind of an easy way to plot these, basically to take our data for each day that we're going over. Let's take our minimum step and our maximum. Really active periods at night. Oh, try vanilla. What are you talking about? Oh, this? Getting up to go to the bathroom, right? That's got to be what that is. All right, so basically I'm finding like the maximum and minimum day step within that day that we're plotting. And then I can query where series ID equals. Oh, we should also take this series ID. And step is greater than or equal to the min step. And step is less than or equal to max step. All right, so All right, so if I do this for this one, break out of it, step min, step max. All right, so the events of onset and wake up for the first day, a lot of the times there were none because they got it late in the day and then it was before they slept the next day. But if I plot all these and we look at the events from this last day, lots of days here. Okay, so maybe even this last day might not have it. Yeah, unfortunately. Basically, what we want to do is iterate over these rows and then take our axis, vertical line there at the step. And let's make this color equals red. See if this works. Hey, someone, thank you for the bits and boops and bops. Wow, Tommy Ned gifted 5 tier 1 subs. That's really nice of you, Tommy Ned. How long have you been watching? How did you find my channel? I'm interested to know. What led you to want to sub? Appreciate that. Following since November 6th, so a new follower. Pog. Yeah, very cool. Okay, so strangely, this second day, even though it looks like there's sleep, it's not labeled as an onset and a sleep. But now we're starting to see where the sleep periods are because you can see the onset and the wake time in most of these days. Because I'm going by date, that means this person goes to bed after midnight most of the time. Is that right? I guess so. It's supposed to be children wearing these. This kid needs to get to bed earlier. Now, some interesting things I noticed too was that with these labels, and they told us this, if the sleep period, if someone was sleeping and then woke up and then went back to sleep, if they were up for more than 30 minutes and then went back to sleep, it only counted the longer of the two periods. So keep that in mind. And that's something that I worked on with post-processing. So my process to kind of solve this problem was a little bit convoluted and ended up not being necessary as I thought. But this is how I decided to approach this. Because there were a lot of examples of series where the sensors were offline, I wanted to first detect those periods. So let's pick a different example maybe where there are a lot of missing values. And the way I can see that is if I go to our events file, and they actually gave us a night for each of the series and then the step of the onset and sleep. But if there was no onset or sleep for that day, they give us null values. So let's look at if step is missing, this is going to be, let's make a new column called missing. And let's group by series ID and do missing sum of this and sort values. So now we can see some series had no missing days. Like every day had an onset and a sleep time accounted for. And some of these way down here Let's make this a plot. Make this a bar plot. So you can see like, okay, this is all jumbled mess. But you can see some of these up here had a lot of missing days. And like most of them maybe had, this is ×2, so like 10 days missing. Because remember, it's onset and sleep is being counted for each day. So let's just take one of these with around 20 missing. So this one. And plot this one. Then we can see the days where the sensor measurements did not show we awake or asleep. Okay, so here, this is a good example. This one's all messy when it occurred. This looks like a sleep, waking up and then sleeping again, but they only counted the longer window. Then here, like the sensor went offline, and here something's wrong. Like the sensor's off because it's not flatlining, it's kind of floating around. And one thing I found was a good indicator of when the device was offline, I think due to the nature of how these features are created, was if the value was the exact same 24 hours prior or 24 hours next, that means it's probably offline. Or another way to do it is to just do the value counts of the exact value. Let me just show you. What did I call it? So this is the kind of detective work you do to figure out what might be good features for a model. Let's look here. DF example. So for this example, what I did was I looked at the angle Z value. I think it worked for all of them, but if I do a value counts on this, it basically tells me how many times in this data set does this exact number up to like the 6th digit occur. You would think that the odds of having multiple values occur the exact same time would be super rare, but that's not the case. There's actually a bunch that the value occurs over and over again. If we plot those, how can we do this? So I think what I did was I took the angle Z, I took this value counts, and then we map this. So now we have a new column, angle Z value count. And now when we plot it, let's actually visually check out when those value counts are more than 2, let's say. So let's basically take this data and let's query where this value is greater than 2. And let's plot that. And let's make the style. Let's just make this dots. And let's make the color. We already have blue and orange and red. So let's do green maybe. Hopefully this is okay for anyone who's colorblind. Oh, there's a lot of points. Okay, so what are we doing here? Rob, you don't read comments on YouTube. Also, I don't know when you usually get online. Yeah, I need to get more of a schedule. So that's why usually it's Tuesdays, Thursdays, and Sundays, nights. But I've been trying to figure out like a daytime to stream. Yeah, I'm not reading the comments on YouTube so that people will come over here to Twitch, but I can go over and check it out. I think I put here, join the chat in Twitch. Where is it? What music should we listen to? Future Bass Essentials? Sounds good. What are people saying? Oh, this is fantastic. Oh, that's nice. Random question about how do you execute Python files from the terminal? I get a permission error. Dark Tobias, you have Python as your logo? You have Python as your logo, but you don't know how to execute a Python file? Are you trolling me? So if you don't have permissions on a file, then you need to chmod it if you're on Linux. If you're not, then I can't help you. No, you need to have permissions on your computer. Permissions to execute that file. Searching. I know your channel from searching ETA tutorial. Yours shows up and I'm watching it. Awesome. Oh, great. Hey, thanks everyone. Join the chat on Twitch. I'm going to put this here. My new Twitch name, which is Rob Codes Live. Bro. Okay. So what did we do here? Can anyone tell me what we did? We're plotting the two data points that they give us, which is this ENMO feature and the angle Z feature. Ah, my beer's going to overflow. I poured that beer way too fast. Look at this. It's dripping everywhere. What am I doing? What am I doing? What do I do? What do I do? Okay, I'm just going to put it here. Just going to put it here. Too much Z access on the beer. Yes. I've been sleeping on this. Oh, it's all over the floor. I poured there was like this much left in the can. There was literally this much left in the can. And I poured it into a glass this big, thinking, oh, I'll be fine. And I guess it was more than that much in the can because it totally overflowed. Okay, so we are given in this competition these two data points, the ENMO and the angle Z, for the sensor of a person for multiple days. We know that these devices can sometimes be offline. Like you take off your watch and you put it on the counter and you're not wearing it. These values don't necessarily just flatline then. They don't just go flatline. Because of the nature of these features and how they're normalized, they actually would jump around. Jump around. Hey. So we ran a value counts on the angle Z feature. And now we're plotting. All right, now here is not only angle Z, but it's turning green whenever that value occurs commonly in this data set. And you can see here, it clearly identifies times when the sensor is offline. Now, it also identifies these flatline periods. So I did a value counts. I think I'm plotting where the value counts is greater than 2. But let's do something like greater than 5. Might still actually show up. But at least my approach to this was, okay, let's first find out when the sensor is offline and then pre-filter the data set. So I made an XGBoost model for each 24-hour period, which would filter out any days in which the device was determined to be offline. And this value counts feature was a very strong feature for that model. Any questions? Hello there. Is this project your challenge to predict my sleep? When would there be another competition? Naomi, great question. No, this is actually a competition. So we did host a PogChamps competition where I uploaded my own sleep data and people predicted it. But what we're talking about right now is a different competition, which was official Kaggle competition. There was like, how much money? $50,000 awarded to the winning teams. My team just finished 7th place out of about 2,000 people who participated in this. And I'm just showing my solution. Now, to answer your other question about when will we host our own Kaggle competition again, that's a great question. I need to get my S together for that. That's on me. Hopefully, maybe next month. Maybe next month we could do something. Would you guys be interested in joining a Kaggle competition? If I hosted it, like a fun one? Let me know in chat. Yeah, so I was pretty pumped that we moved up from 16th place on the public leaderboard to 7th, which is still right outside of the prize money zone. But we did pretty well. All right, so we can identify offline times in this data. And also, you notice here, let's see, when it's obviously offline. Yeah, when it's obviously offline here, well, while this might be a sleep period, it's not marked as an onset and a sleep. So not labeling this time period was important. All right, let's get into the models. So I feel kind of silly because a lot of this stuff that I did with like the pre-filtering, it didn't matter in the end. Like we didn't really end up using it. But it was what got me to the top of the leaderboard very early on. I think I have a screenshot of that. Let me open this. Yeah, I sometimes take leaderboard screenshots. This is like early on when I had a 746. This score kept me in like the top 5, top 10 even for months of the competition. This was really early on where I had this 746 using this approach on the public leaderboard. A lot changed after that. I mean, a lot of the people who are trying really hard wait until later in the competition, so it doesn't mean that much. But still, 746 would have been like, yeah, it would have been like top 75 in the public leaderboard. And that's something I did like 2 months ago. But that approach used this pre-filtering model. So I basically made all of these features about each 24-hour period. Value counts were really important ones. I also looked for stale periods, like when the data didn't move for the longest amount of period in the 24 hours. And then I trained an XGBoost model using group K-fold. This was my model. You can see I'm importing XGBoost, fitting each fold, predicting, printing the accuracy, all this stuff. So while this trains, you can see that you want the validation loss to continue to go down as the training loss goes down. And then I did some analysis just to see, okay, at what threshold can I almost perfectly predict all of the times when the sensors are offline? Because if I can perfectly predict those days, I can just throw them out of the data set for my second stage. So I was looking at this as like a two-stage process. And then these are all my different versions when I was like keeping track of how well they did. And then I trained a final model on all the data, yeah. And I used that in my solution code. So it actually went through, pre-filtered out all the bad days. These are the features that were most important to the model. So like the angle Z value count greater than 1 standard deviation, which makes sense because it's like basically what's the standard deviation of green dots? Yeah, like how it's kind of a weird feature, but like what percentage of the time are the green dots occurring on the plot? This is my precision recall for one of the models. So you can see I was like at the 99th percentile of catching almost all of them at a certain threshold. All of these offline times. I don't know what else to say about this. I'd love to because I'm feeling more prepared. Well, Naomi, why are you feeling more prepared now? What happened to get you so prepared? Can't believe I spilt beer everywhere. At least on a wooden table, you can just kind of like rub it in and be like, oh, that's a beer smelling table. It's supposed to smell like that. It's supposed to be sticky. Okay, so let's get to the deep learning model. Should we just jump all the way in? So my inspiration for the modeling part was the winning model used for a different Kaggle competition. Now you find this in common on Kaggle, and it's partially because it's partially the great thing about Kaggle is that you can look at past competitions, see who won them, and then read their write-up for their solution and try to copy it. And there was this other competition that I worked on. It was to detect when people wearing sensors like this one, like the sleep one, wearing accelerometers had Parkinson's gait occurrences. So they'd like have these moments where they couldn't walk correctly. And we're trying to detect that in very similar sensor data. Now that I'm thinking of it, they actually didn't in this competition. I think they give us the raw data. Maybe that's why that model worked so much better there. But the top scoring person in this, it's got to be here somewhere. No, I've read it. Basically, just use a transformer and an LSTM. Transformer for feature extraction and the LSTM for identifying the moments. And yeah, multi-headed attention as their encoder. And then added all these LSTM layers to try to identify when the events occurred. And I pretty much copy this directly. Humans learning about deep learning, very meta. Isn't ensemble modeling the most widely used approach there for better score? So you have to remember, ensembling is just the idea that you take many different models and let them all vote on what to predict. So ensembling is just a way of generalizing by making lots of little models or multiple models. So my team ensembled both my model and my teammates' models' predictions together when we made our final predictions. But you're probably thinking of like a gradient boosted tree type of model, like LGBM, like GBM or XGBoost that I showed earlier. Those type of models are commonly used for tabular type of data. So yes, those are very common, and those are ensembles. Just the architecture of a boosted tree model is that it creates a bunch of little models, a bunch of little trees, and then creates a prediction based on what all those models predict. So I don't know if that answers your question. But yeah, they're popular, but deep learning here still beats it. Okay, so let's look at some of these encoder LSTMs. I don't know if this is bad, but I like to, instead of having just one like run.py file, and it makes my code very messy and hard to follow, I like to just create a brand new file each time I run an experiment. Mainly because I can tweak little things and then I can compare them using VS Code's compare. Like I can see, okay, in this run, I changed the block stride. Yeah, I can see this all in weights and biases. But let's say I like fixed a bug in the actual code, then I can see those differences. And I don't have to worry about different Git commits. For me, it helps me actively develop really quickly and not have to worry about maintaining one run file that is backwards compatible. Or I want to be able to run one of my earliest experiments and just know that this will run from end to end because all the code is in here. Now it does have some imports of other code, like some later versions have like the metric code that I wrote or optimized. But if we look in here, okay, some of the things that I'm doing, basically getting blocks of data, reformatting it. Let's find the actual model. This is loading all the data into RAM. Okay, so these are the features that I actually used in the model. And let me look at one of my later models. This model, I ended up just using these features like the rank, the angle difference. So I took that, like the angle, and I basically did this to get the difference. Take this DF subset, DF example. You just do angle Z, diff. And that tells me how much this feature has changed in one of those 5-second steps. So if I plot this, you can actually see it stays very low when the data is stale, when the device is offline, and then it really jumps around. But it kind of lets you see like the motion of the features. When I was doing the sign language detection competition, these features seem to help because the model can know like when your hand. Sign language competition was like the model knew when your hand's like this or making a letter, but the diff features kind of let the model know, okay, the pointer finger is moving down and to the left, like that sort of motion feature it was able to capture. So similarly here, it's like, okay, what's the change in the angle? And I actually didn't try too many of these features because I figured the model could pick up most of this, but just to nudge it along with that difference seemed to help. And of course, you're such a stereotypical data scientist, not an enterprise software engineer. Yeah, I'm not. I do appreciate that you use full words in your variable names and not crazy abbreviation acronyms. Yeah, I mean, that's just so I can keep track of it, right? But I think that when you're fastly prototyping this stuff, yeah, doing a bunch of files is nasty. But at the end of the day, if I had a single model that I was like, okay, this is my final model, I could clean this code up and, put it into different folders for the data processing and different files for the modeling. But for here, it works. And I've done the other way too. Like the other way, you just have a config file, and then you run it on your training script. And as long as you're not doing something complicated, that can work pretty easily or pretty smoothly. All right, so where's my model? Okay, so here's the encoder layer. You can see the main thing with this is the multi-headed attention, which is kind of its way of grabbing the features that are important to the model. The main parameters you tune in multi-headed attention or any transformer model, the big ones are the model dimensions, and then the number of heads in the multi-headed attention. That's kind of telling it how many different relationships between the features should it look for, I guess. So like the more you have, the more relationships it can see, but also the more it can overfit. So like most things in deep learning, you're trying to pick good parameters for these that doesn't overfit to the training data, but also lets you pick up on the relationships in the data. That makes sense? No need to spend time productionizing a proof of concept. Yeah. All right, so this is an encoding layer. This is kind of like the feature extraction part. So you'll notice that this is TensorFlow Keras code, but it looks pretty similar to like a PyTorch model setup. We have an init, and then we have a call, which is sort of like what you have with PyTorch models. So they're kind of becoming more and more similar. I just use TensorFlow here. I was planning on refactoring it all to PyTorch, but I used TensorFlow here because that's what that winning solution from another competition used, and I kind of use their code as a starting point. So this is something my teammate suggested I do, and it actually helped out the model a lot, which was adding all these convolutional layers to the model before running it through this encoder layer. So this is the kind of flow of the model going through these CNN layers, convolutional 1D layers, then to a dense linear layer, which kind of put in the model dimensions. Now, I don't know how to explain this stuff very well, because I know that this is just going to sound like gobbledygook to anyone who hasn't spent time with it. But then the encoder layers and then the LSTM layers. These are the layers that kind of extract the moments where the probabilities are going to be high of one of the events. Oh, the other thing is, oh, this is kind of cool. What did I have it predicting? You think about it, in this data that they gave us, the events, the onset event and the awake events are just a one data point in this whole day worth of data. So I did a bunch of prototyping of different ways of kind of ramping. It's kind of like label smoothing around the true label. So I tried obviously just predicting the moment of the event, and the model had kind of a hard time of predicting that because it was just so instantaneous, and it had to kind of just predict that perfectly. And then I tried a bunch of different ways of ramping that up and down, and I actually parameterized that in my model and compared how the results look. So if we look at these, we look at this config. I was predicting if it was the sleeping time was any time in between the start and the end of the sleep cycle, it would be 1. Otherwise, it'd be a value of 0. And then the onset and wake up ramp, I tried different ramp types, and I parameterized the width of this ramp and what type of ramp. So linear ramp, it's just this, like going straight up for whatever window I had. Quadratic, and then cubic. Yeah, so the quadratic of 24 steps after a bunch of tests, that's what showed to be one of the best in this data set. Hey, I was wondering how you manage the time to be able to focus on work, being a data and doing Kaggle. I'm early in my career. I feel like I'm just tired after work, let alone working on something outside of work. Yeah, you have to kind of love it and enjoy it. If you don't enjoy it, you're not going to do it outside of work. And that's fine. I don't think it's like, you meant dad. Oh, and being a dad. Yeah, see, you're like me. You type the word data so much probably that anytime you have any other word that starts with DA, you automatically type data. That's what I do. But yeah, part of it is like my current job, they're very encouraging at H2O of their Kaggle GMs, and they're supportive of us competing in competitions. So that gives me some more time to compete in competitions. But then also I just find it fun. It's kind of like playing chess or playing any other video game. Once you kind of get hooked, it's like, I enjoy this too much. It's not like work. And not only is it not like work, I feel like I can't stop thinking about it. And yeah, being a dad, I sometimes have to like mentally tell myself, this isn't that important. Stop working on it. And then I also try to work on these, just like, one nice thing about a Kaggle competition is it ends, right? And once it's over, you kind of don't have to think about it ever again if you don't want to. And the nice thing about it is you're just doing it for fun. So if you lose interest in it, you just stop. No one's going to make you keep on doing it. It's not like your job where you have to keep on working on this project you hate for 6 months. You can just stop unless you're on a team. So yeah, once it's over, then I find I can take a break and like make up for lost time. I also acknowledge that burnout is real and life responsibilities suck and take time for personal health. Yeah. Yeah, that's totally true. Try vanilla. The other thing too is like when I'm going through these solutions, this stuff, it looks like I just did all this in the first day. It looks like or you might get the feeling that I did this all very quickly, but really it was like one night here, one night there, and then added up over months where it's like, okay, now I actually have a good solution. And then on top of that, it's like, once you've competed in a lot of these competitions, it's almost like you've built up this base understanding of how to approach these competitions, and then you can repeat that, and like incrementally it becomes so much easier and easier. So 5 years ago when I started working on a Kaggle competition, I had no idea where to start. And yeah, I didn't do well in them. I didn't do well in those competitions because I didn't have enough time to do well in them. But when you fail in those competitions, like for a couple of years, and then you start to get the hang of it, then you like, everyone else is starting the competition at ground zero, or not everyone, but all the newbies. And you're already like, okay, I know 10 things to do off the start. And I already have code written of how to implement that. Also, ChatGPT helps speed up some dumb coding stuff. For sure. Yeah, like for instance, an LLM wrote this create ramp. It wrote this create ramp, or an early iteration of this function for me, and then I added to it and I asked it to improve it. But I knew I just wanted something that would take this input data and create these ramps. And like I could write that, but just explain it clearly and get the code, make sure it works. And I went from there. Hey, Rob, learning pandas and came across your videos on YouTube. Doing a great job. Hey, thanks. I'm glad that it helped you. And you're watching without audio. That's interesting. Are you listening to the text, or are you reading subtitles? Sounds similar to exercising and turning exercise into a habit. Yeah, for sure. Like I run almost every other day or so, and I'm still super slow. But the first time I tried to go out and run, I could barely make it around my block without like being exhausted. And I couldn't imagine running a marathon. And I kind of ran a marathon last year. But I can run like 10 miles and not die nowadays because I have years of still running very slow. Keep that in mind. But it's the same thing with all this. It's like, don't expect it to happen overnight. Rob, how far would you say you went? How far would you say you went in data science? Like, how professional are you? How hard is it to reach that level? I appreciate the question, Param. I don't know. How do you quantify how far you went? How far you went? It's an interesting question. I don't know how to label. Give me an example of like what a professional level is. Hey, Rob, I'm still a data science student starting out Kaggling. How transferable are Kaggling skills to actual work? I'm yet to have work experience, but I want to hear from some perspectives. So for me, in a lot of ways, the Kaggle work, it's like, in a lot of ways, real work is nothing like Kaggle, because in real work, or in work outside Kaggle, you're having to define the problem and gather the data and convince people of why you should do things, and trying to get labeled data when it doesn't exist, and all these other things. So those are skills that you need to build that you won't get from Kaggle. But there are some foundational things specific to machine learning and how you need to validate models and create models that you can't learn as well as you can by doing it on a place like Kaggle. And if you want to have a job where you're actually building the models, and that's your main thing, then Kaggle can be a great place to help make you better at that. If you want to do more of the, creating the Kaggle problems and thinking through that, less of the technical part of it, then you might not need Kaggle as much. I mean, or you could do any job. You don't have to do data science. There's a lot of work that isn't specifically coding. Most of Kaggle too isn't necessarily coding too. It's just thinking through the problem, exploring the data. It's not a specific question. Just say some of your experiences. For example, I see people don't know some very basic stuff like putting subtitles on movies. Made me wonder how much I actually know. Things that seem like an everyday job. Some of my experiences. Yeah, I mean, I've over the years been able to work for a bunch of different companies and work on different data sets and with different types of people and how they work. I feel like I have a lot of experiences. I can't think of any good ones off the time. Interesting. Programming is exactly programming professional is like. Thanks, SimulShift. The real secret to most software engineering job is that nobody really knows what's going on. Hopefully someone knows what's going on. Usually that one guy who knows what's going on a lot better than everyone else. And then you're just trying to keep up. But yeah, so I mean, in software engineering, a lot of times you're just trying to build a feature. You're trying to implement something that's very clearly defined. In data science, sometimes it's not clearly defined, or maybe I'm making it more ideal than it is what software engineering is because I'm not that experienced in software engineering. But it seems like more so in data science, people don't even know what questions to ask to get at the solution they're looking for. Like if I'm building a website and the person says, I want a button here in the top right corner that does this, then they can write that down. Software engineer can do that. But with machine learning, it's like, I want something that can predict the stock price tomorrow. And then the data scientist has to be like, well, you can't do that with this data. Or like, I want to be able to predict, if a person's like logos in images. Okay, we need a bunch of labeled data with the logos. Oh, we don't have that. Those are the kind of conversations you have a lot. Okay, so we talked a little bit about this model. I just do want to show you guys. I do like weights and biases. There's also this Neptune AI. Like both of these, I think are really good products, and all they really do is help you track your experiments. Because especially with something like a Kaggle competition where you're trying to get every little inch out of your model. Let's play some music. You're going to be trying different size of the model, all these parameters in my training script. You might be changing how much augmentations you have. I didn't even talk about how I added this cut mix augmentation, this rolling augmentation. And augmentation sometimes can help your model, but if you put too much of it in, it can hurt your model. So you want to run experiments and see how well it each does. And that's what I was using weights and biases for. See if this dark mode looks better. So basically each of my experiment was tracked here. My configuration file, my configuration dictionary that I showed, would have all the parameters here. I'm hiding a bunch of columns, like the number encoding layers. If I was to change this, I could see how those encoding layers changed. Most of them all I had set at 5 layers. And then I could see what my score was for those. And not only that, I could kind of track to see, are they starting to overfit early? So you can see my validation loss. All my models were kind of starting to overfit after 20 epochs. Even though the loss function was overfitting a little bit, the evaluation metric was still sort of improving. So I would keep training for longer than that. I like to look at these plots because this was something I've been using recently. Let me turn this off. Fold number. Let's compare a couple of these. Yeah, okay, so I have only a few runs selected now. This is the validation loss over the training loss. So what this helped me to see is when it was starting to overfit. So basically anything over 1 meant that the training loss was starting to get much larger than the validation loss. And I could see with certain models, it would start to overfit more. Let me turn this on. And you can see this one like overfit a little bit less. I like this too because it lets me see quickly what's the difference in these models. So I could see only the features where I changed stuff. So like the number of features changed here, my batch size changed, everything else was pretty much the same. I can compare side by side. Yep. So definitely got to use something like that. So I've used TensorBoard before in the past. It's basically a local version of this, but Weights and Biases has a local version that works also. TensorBoard's kind of like the most lightweight, I'd say, version of this. And you don't have to use TensorFlow to use TensorBoard. You can use PyTorch and then use these. Just have it logged to a log directory and that'll display it for you. Also back in the day, I would just have it write to CSV files and that was good enough. What about TMLflow? I haven't used it. Is it good? TMLflow, or did you just misspell? I think you just misspelled. Yeah, my MLflow is another one that does a very similar thing, but I just don't have a lot of experience with it. Hey, Rob, for the feature importance of the model, you use the XGBoost itself. Shouldn't we use SHAP values to meet the consistency and accuracy criteria? Please explain a little bit. So I think you might be inflating what Shapley values actually give you. So Shapley values let you see for a complicated model. And let's just look at my XGBoost. My XGBoost as an example. This is my feature importance. Now the feature importance of the XGBoost model is basically how many times did the model use this feature to split a branch in the tree that it created. So that can be deceiving because you don't necessarily know if that split caused the value to go up or down in your prediction. You don't really know the relationship between the target and that feature. You just know it's more important because it's used more, which actually doesn't even mean it's more important. It just means it's used more. For other reasons, like you could split on a big feature that if you removed, ruined your model's quality, but it actually doesn't show up high in this plot. So in many ways, this is deceiving. But what it really comes down to is you have this complicated nonlinear model, and you don't actually know all the relationships between the inputs and outputs. It's to some extent a big black box that we can't explain. If we could explain it simply, it wouldn't be the machine learning model. It would just be like a simple linear model. But Shapley values can help you to understand those relationships a little bit better because they allow you to visualize and to see, okay, is this feature actually making my prediction go up or down? So I didn't really care. I just cared about, is my model getting better or worse? So I had no reason to pull up Shapley values. That being said, in the real world, I have used Shapley values a lot, mainly to explain to business people why the model's doing what it's doing. And it's never perfect because it can't explain these complicated models. But at least gives you an idea of like, all right, this feature is correlated with this feature, when it goes up, it's correlated with the model predicting higher values or lower values or whatever. Does that make sense? So yeah, a lot of stuff that you hear about and you read about and you think, oh, you have to do that when you're doing a machine learning project. You have to look at Shapley values. Not really. It's not really necessary. Just because you heard about it. There's no like set book on exactly steps you have to take to create a good model. And especially on Kaggle, what people care about more than anything is how accurate is it on a test set, on a holdout test set. And some people don't do exploratory data analysis at all, really. They just start building a model. And if they do a good job at it, they might not need to. How far are we away from synthetic data generation? So in my experience, there's there's really should be no reason to generate synthetic data. Because if you think about it, what you're trying to get at is that the model is smart enough to create fake examples for you. So then what's the benefit of that? To train another model to predict based off of that synthetic data? I mean, it is useful in a lot of scenarios. But more so in the sense of like augmenting data, like kind of like when you're doing image classification. It's very common to augment your image data by doing things like flipping it or cropping it. And this is in essence creating new data samples for your model to train on. It's a weird example though. It's probably just because of this dark mode on. Yeah, so like these augmentations, it's like creating new data to train on. That can be helpful. But actually creating synthetic data, like this thing called SMOTE, I've never actually found this helpful. If you have a model that's smart enough to create synthetic examples, then you should be able to create a model that can predict given your existing data pretty well. So SMOTE is like a way of trying to approximate each of the features and then create new synthetic data. It never works. It never really works. It's a good idea. It sounds cool, but it never really works. Are you sharing any of your code anywhere? Not as of now. I haven't shared any of it. But we should look at like what... Kind of embarrassed by my code. We should look at some of the top teams, what they did. KMAT was in the first place, like the most of the end of the competition. And he always has really good solutions. So this is like what the second place person in the whole competition did. We'll look at that, and we can read their code because they'll make it public eventually. Not tonight, probably, because they usually have to clean it up and stuff. What work do you do? I work in data science. Oh, you found my about section. Thanks for your explanations. I was reading this article, and this guy from Google Brain and saw this. What did you see? Did you paste something? Because I didn't. Oh, you pasted this. Interpretable machine learning with XGBoost. So this is like Shapley. Yeah, so the point of this, the point of the Shapley values here is that you want to be able to explain this model to like a business user. They get the TikTok algorithm or the YouTube algorithm. For the most part, they just optimize it to keep you on their website. That's just an optimization. They feed in all these features and they let it optimize to keep you on the website. But you can't really explain exactly what's going inside the model. But then let's say vice president of TikTok or vice president of YouTube says, now I want to understand what does this one feature do to our predictions? Then you'd go run Shapley values on it to try to explain it to them. But if you're really trying to find a direct correlation between one feature and a target, it's probably better just to do like normal statistical approaches where you have things like p-values and you can control for other things going on. It's like these two worlds of machine learning and statistics, and Shapley is kind of like a way of taking at least trying to make the machine learning explain itself a little bit. Hey Rob, I wanted to ask you if you have experience with ML ops and how much you do as an ML engineer. Do you use or have to work with it? Also, can you recommend your study material if you have any for ML ops? I'm not like a pure ML ops guy, but we had my last job like a pretty sophisticated pipeline that was built to run these batch jobs and a bunch of video files. It was really cool. And that's like my deepest experience with ML ops. I think the people that work at large companies that productionize machine learning models, they're really big companies. They have kind of like their own ML ops workflow. And if you join that company, you learn about it when you're there. And if you're at a smaller company, there are some tools out there to help you with ML ops. And then there's most companies that like try to build it from scratch themselves. And we were one of those companies that we're a group team that it seemed like the ML ops people were trying to build everything from scratch. And it worked. Oversampling. Oversampling, same thing as like trying to do the synthetic data thing. Oversampling helps you, like, if you're trying to predict a binary classification and it's really imbalanced, then if you're doing like a cutoff in your prediction threshold, it would just be much lower. It all has to do with what you're trying to optimize for. Can use class weights or Tomek links instead of smoke. Okay, so there's some other approaches. Are they better? I tried smoke on a ridiculously imbalanced data set with lowest one sample up to thousands. I tried smoke, but not really working out. What's your solution if data set that contains one sample? If it contains one positive sample in your data set, you're screwed, man. You just don't have enough data to do machine learning. There's a point where the data is small enough that machine learning is not necessary or helpful. All models are going to be wrong. All models are wrong, but some are useful. That's the famous quote. Machine learning models are not useful when the data is too small. Like if you only have one example. A model is just extrapolating and trying to generalize the relationships between the data and some sort of outcome. And how can you do that if you only have one example? Haven't used it, but theoretically it works better than Smote. Yeah, there's no such thing as free lunch. Yeah, you got to watch out for that. Because I'll believe it when I see someone win a Kaggle competition using it. That's when I'll bite. But I have yet to see someone win a Kaggle competition and be like, hey, it was because I used Smote. Nope. I'm late, but I'm excited to see this. After a streak of success, this competition brought me back to the Dunning-Kruger effect. Ice at night. Oh no, what happened? What's your Kaggle username? Is it Ice at Night? So you didn't have a great experience with this competition? Yeah, part of me is just riding high because we did so well on the private leaderboard. I mean, could have done better, but it's nice when you jump up into gold from down here. I've had it many times where I do the other way. So I showed the machine learning tracking. I showed most of my code. I didn't really show these augmentations. I spent so long exploring this data set, like these weird patterns in the data, which ended up not revealing anything. And I probably should go read some of the top solutions to see if they did find something. But, basically all these different post-processing ideas that I had to improve our score. And one of the things that came up a bunch was if I pull down the recent, it is up to date. Oh, I don't think I pushed a lot of these notebooks from my other machine. Okay, but I can show you here. So I think this was a result of the labeling software they used. But there's this odd, it's in the events file. There's this odd abnormality in the data that we noticed. So in our events file, which is basically telling us when the person woke up and when they went to sleep, if you look closer at the timestamp values, first thing you'll notice is that it's always on a round minute. So let's do this. Look at the events. To date time. Right? So most of these are to a round minute. So if I do like DT second, and then do a value counts on this, all of the labels were on the round minute. Like the second was always 0. So, okay, the labeling software only let them label up to the minute. But if we go to events, do the same for minute. This is minute within the hour. notice something strange. So if we look at just the onset events, and do a value counts on this, and then we sort by the index, and we plot this as a bar plot. Notice that this is not random. It's not that the onset minutes are randomly somewhere between 0 and 60. There's actually spikes here, and if you look at it, it repeats every 15 minutes. So my teammate realized that if you actually just do this, minute and hour mod 15, and then if you plot this, you can kind of see the relationship. All this is to say, and then if we do onset and wake up as two different ones. But all this is to say, found this weird data quirk and I wasn't really able to exploit it in any ways. So wake up actually had a different kind of trend than the onset trend. Don't know what was going on here. We tried looking at the duration of the sleep events. Like maybe they mark the start and then they mark the end. The only thing I could kind of come to the conclusion of was that their software for labeling allowed them to zoom. And if they zoomed in closer, then they could mark these smaller windows. But if they're zoomed way out, then they would more likely pick on a 15-minute increment. Just a guess, but very weird data issue. I tried taking our predictions if they were in a certain window and bumping them to the left or the right to try to get closer to the actual ground truth, but nothing ended up working. I am late, but okay. I'm Cody Null. Cody Null, is this you? Oh, cool. You're in the U.S. There aren't that many U.S. Kagglers. So what happened to you on this one? Oh, it's completed now. So used to it not being complete. 144, that's not bad. 144th? I bet you shucked down, though. Is that why? You went down 29? So, I mean, that's not too bad. Like I said, if I didn't have my teammate, if I didn't team with this incredibly awesome, smart Kaggler, I would have been like, I think my best one was 814. It would have been here. First time chatter. Gridiron Geek, welcome. Hi, Rob. Do you recommending becoming an expert in one domain or branching out? I work as a data science in finance, would like to expand into sports betting or LLMs. I'm nervous switching would hinder my career growth. All right, here's just my take. And granted, this is just my take, so it's not for everyone. But I have changed jobs a lot over the years, and it's always kind of worked out in many ways for my career. It's been a net positive. I love learning new things. I'm more excited working on projects when it feels new. I like meeting new people. Now, I do feel like I look back at my career and I think, I liked a lot of the people I used to work with. It would have been nice to have been friends with them for decades and see them every day. Because most of the places I worked, I really liked those people. So the downside to me is that I hadn't been able to build those long-term connections with people. But in tech, especially if you work in finance and you want to get out of it, just start applying and try to jump around. I mean, it's kind of what people do. And usually, almost always, you can get more money as a result of switching jobs. I mean, once they have you working for their company, you can get incremental bumps, or you can jump to like a management position or something. But when you're changing jobs, it's like they let you level up a lot more. That's all I can say. I got caught up in public model and assumed everyone was doing 1D, 2D CNNs. I had a tough time improving. Yeah, I saw that public model. And ensembling was unique for this one, so I didn't get to it. We had a real trouble actually getting a boost from ensembling. There are more jobs available for generalists and fewer jobs available for specialists, but specialists average paid much higher. Yeah. Or you become like a specialist in being a generalist and you become a consultant. I was close. I also feel like me being in the finance space makes it harder to enter other fields. Before I enter the next level of my career, I want to make sure that I'm in a field I enjoy, but I am afraid of the loss of salary I might experience if I switch. Yeah, so I guess I've only switched careers when it's helped out my salary. But if you're trying to get into like these really competitive fields, you're already paid really well, you're trying to get into sports betting or LLMs. I mean, I don't know much about sports betting stuff, but LLMs, you're going to be working like in a startup. I don't know. I just don't like the feel of sports betting personally. But I don't know how much they pay. You'd be surprised, though. Can you have a rolling window of 15 minutes and aggregate all the data beforehand? I don't know if it can help. Juria, thank you for the suggestion. Yeah, we tried a lot of features like that. This competition's over, so I'm about to wipe it clean from my brain pretty soon. I don't need any more. Don't need to think about testing out other stuff. Okay, second place, KMAT's released his solution. Let's just look at that to see what a true master, a master soon to be grandmaster. Okay, 3. So KMAT needs after this one more gold to become a Kaggle grandmaster, but still probably one of the top competitions. Ranked 109th. I'm surprised not higher. First stage, pre-process feature engineering, event detection, and sleep awake classification. So 1D model. Then use peak detection. Then a second stage, use machine learning instead of post-processing that is difficult to adjust. Rescoring by light GBM that can consider limitations of 2 events per day. Okay. Third stage, predict as many events as possible just by shifting the step of the base prediction above. I tried all that. Shifting. Yeah, we did that too. Like shifting the prediction to not be on the exact minute. It's where I tried like tons of this stuff. Combining average in WBF ensemble. So this, you could spend a whole weekend reading the top solutions of this competition, and you'll learn so much from this solution and other solutions out there. Wow. So from 0.26, 0.832, 842. So this third stage really helped a lot. I don't still understand the third stage. Light GBM to break. This was kind of, I think, what we were trying to do with the minutes. Small offset is effective to cope with the strange pattern of ground truth every 15 minutes. Oh. So I was trying to do this heuristically. He was able to figure it out using light GBN. Wow. That's really good. What was the optimization of the light GBM model? So optimizing against the average precision metric? Wow, this is really good. You guys should read this. And the other winning solutions when you're done. Maybe you need a SHAP to understand the third stage. Yeah. Appreciate the advice. Yeah, thank you, Gridiron Geek. All right, I think I'm about done. I'm going to finish drinking my beer, which I spilled everywhere. We have some viewers on Twitch. If you're not on Twitch, so just some promotional stuff. I have a YouTube channel. I have a Twitch. They're all at the bottom of the screen. You can follow me on X, whatever that does. And we have a Discord server. So if I go into the chat and I type !Discord, hasn't been working recently. But if you look in any of my YouTube videos, I have my Discord server linked. We're going to go ahead and raid someone on Twitch. Who do you guys want to raid? Who do we raid? Let's look in software and game dev. Someone's doing Advent of Code. See if anyone's doing Python. I am doing Python. Chrissy Codes is... not doing Python. I should probably share my screen. Code Rock. This is person writing Python code. Uh-oh, this might contain drugs. Oh, it worked for you, dude with one leg. Nice. Hurrah. I've made a few projects in DL. Any advice on starting with Kaggle competitions? Just jump in and start with one. Don't ask questions, just try. Just try. You could do like MNIST or something like that. Okay, so this guy's doing Advent of Code and he's writing Python. So let's raid him. Nug run only. So raid As a beginner, this kind of retrospective streaming is very helpful to me. I'm glad you hung around the whole time, Fu Trio. All right, we're going to raid now. Thanks, everyone, for hanging out. I really appreciate you guys hanging out with me. And make sure that you bring the energy to the next person that we raid. And I will see you next time. Keep in mind, this channel is intended for mature audiences. All right. Not my channel, the one we're going to raid. All right. Thanks, everyone, for hanging out. The raid has occurred. And I will see you guys later. Bye.